Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about temperature is one of the most measured variables in processes, since almost all physical phenomena are affected by it. In this table, we can see the measurement field of different temperature measurement instruments, which I will explain in this video and later. The physical phenomena in which the temperature influences and that for this reason are used to measure it are 1. Variations in volume or a state of solids, liquids or gases. 2. Variation of resistance of a conductor, which can be resistance probes. 3. Variation of resistance of a semiconductor, as in thermistors. EMF or electromotive force, created in the union of two different metals, as in thermocouples. 5. Intensity of the total radiation emitted, as in radiation pyrometers. And 6. Other phenomena used in the laboratory, such as the speed of the sounding gas, resonance frequency of a crystal, etc. In this video, I will talk about the first ones. The glass thermometer has a glass device that can contain, for example, mercury, and that when heated expands and rises in the capillary tube. These are the working ranges for fluids used in addition to mercury. Bimetallic thermometers are based on the different coefficient of expansion of two different metals, such as brass, monel or steel, and ferronickel or invar alloy rolled together. Bimetallic sheets can be straight or curved, forming spirals or helices. A typical bimetallic thermometer contains few moving parts, only the pointer attached to the free end of the coil or helix, and the bimetallic element itself. The shaft and element are supported by bearings, and the assembly is precision built to avoid friction. There are no gears that require maintenance. The use of bimetallic thermometers is permissible for continuous service, from 0 to 400 Celsius. For local indication, bimetallic orientable sphere thermometers are preferably used. Thus, the operator can read the temperature remotely from levels other than that of the installation. The instrument's accuracy is ±1% and its measuring range is -200 to 500 Celsius. Bulb and capillary thermometers consist of a bulb connected by a capillary in a spiral. When the temperature of the bulb changes, the gas or liquid in the bulb expands, and the coil tends to unwind by moving the needle on the scale to indicate the temperature rise in the bulb. There are 4 kinds of bulb and capillary thermometers. Class 1, liquid actuated thermometers. Class 2, steam actuated thermometers. Class 3, gas actuated thermometers. And Class 4, mercury actuated thermometers. Liquid actuated or Class 1 thermometers have a liquid field measuring system, and since their expansion is proportional to temperature, the measuring scale is uniform, with short capillaries up to 5 meters, and to avoid errors due to variations in ambient temperature, only the measuring element has to be compensated. In longer capillaries, the volume of the capillary tube must also be compensated. The liquids used are alcohol and ether. The measuring range varies between 150 Celsius to 500 Celsius, depending on the liquid used. Class 2 or steam actuated thermometers have a volatile liquid and are based on the vapor pressure principle. As the temperature rises, the vapor pressure of the liquid increases. The measurement scale is not uniform, but the distances between divisions increase towards the highest part of the scale. The system pressure depends only on the temperature in the bulb. Therefore, it is not necessary to compensate for the ambient temperature. In the Class 2A thermometer, if the bulb temperature is higher than the ambient temperature, the capillary and the measuring element are filled with liquid, being necessary to correct the indication in the difference in heights between the bulb and the measuring element. In the Class 2B thermometer, if the bulb temperature is lower than ambient, the system fills with steam. Class 2C operates with the bulb temperature above and below the ambient temperature, and Class 2D works with the temperature of the bulb higher, equal, and lower than the ambient, using another non-volatile liquid to transmit the vapor pressure. Gas-actuated thermometers or class 3 thermometers are completely filled with gas as the temperature rises. The gas pressure increases proportionally, and therefore these thermometers have linear scales. The pressure in the system depends mainly on the temperature of the bulb, but also on the temperature of the capillary tube and the measuring element, being necessary to compensate for the ambient temperature in the measuring system. Mercury-actuated thermometers or class 4 thermometers are similar to the class 1 ones. They can have box compensation and full compensation. The standardized scales, according to DIN 16.203, are those that you can see in this table. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adios! From levels other than temperature, and therefore this temperature